about myself. That's followed by, so I'm going to give you a brief introduction about myself. And then today I'm going to talk about one of the projects that I have done with the team, actually including Patrick Manuel, who is the next guest speaker. I think 8, right? You say 8 o'clock. Okay. So he was my former colleague in Manchester, but now he joined UE. So, but we still work very intensively together. No matter where he goes, we need to work together. Okay. Cannot escape from us. All right. Okay, so this is a bit about myself. Now I'm a reader, that means associate professor in engineering management at the Department of Civil Engineering and Management at the University of Manchester. So this is my full-time job as an academic. But besides that, because in the UK, other than working on your research, you also need to carry different leadership role. But it's up to you what kind of leadership role you want to carry. And at the moment, I am the faculty head. Faculty stands for Faculty of Science and Engineering, and head of the internationalization of ASEAN, Japan, and South Korea. So what that implies is I also look after research collaboration, teaching collaboration across different research institutes in those regions. And that's another reason why I just shared with you guys earlier. I just returned from Japan because I have some personal research there. On top of it, also helping university to facilitate different kind of activities over there. Okay. And then I'm also the deputy head of research for School of Engineering. So quite hectic because of all the different leadership role and on top of my research. And and just stay back a little bit. Okay, when I draw this timeline, I just cannot help myself laughing. And it's really 20 years already. Can't believe that. Okay, so you can calculate how old I am. All right. So I am around 20 years ago, over 20 years ago, actually. I got my first degree in Hong Kong, Hong Kong University of Science and Technology, HKUST. But at that time, I was not studying technology or science or engineering. At that time, my first degree actually is in business and also social science. So I major in business, minor in social science. And after that, I just feel I don't want to study anymore. Study is so boring. So I went out to work, okay? Because if you're studying something very applied, like business, the best thing to learn is not staying in school. You need to go out to learn. So I spent really a decade actually working for different multinational firms, focusing on improving supply chain management, productivity, health and safety, et cetera, and then working in different countries as well. And I think something, it need to unmute the mic. I can't hear.
Okay.
Good.
All right.
Yeah. Okay. Let me go back. Can I? Oh, here. Okay. So after all this, okay, I just realized how problematic, although I work for manufacturing sector, but I start to realize how problematic actually in construction sector in terms of health and safety, because the final bit of my career is I am in charge of helping them to build distribution hub, okay, in Australia and as well as in the US. And then I just realized what's going on with you guys. I'm the client, okay? But I work with contractor and subcontractor on the site and realize how problematic it is. That triggers me to go into this field. So I just dig the hole and jump to the hole for myself. I returned to do my PhD and master's in the States, okay, in civil engineering with a particular focus in health and safety. So I spent a couple of years in US doing all this, and after I finished that, just jumped to the UK to start my lectureship. So that is briefly my journey. But because of all the background, all the international experience, plus my business, social science, and engineering background, when I do my research now, basically, I'm applying different lenses to it in order to find the common ground. Because what I found is people who are working in social science space, they are not, of course, they're not engineers, okay? So they don't understand the technical side of things. While people who are working in the technical side of things, they don't really understand human behavior, how you drive people change. So that's why I think that it's important to have this kind of interdisciplinary lens to solve whatever problems. For me, it's health and safety. So that's the reason why I draw the bubble in such a way. So that is basically about my messy background, kind of spreading across so many different areas and countries. Okay. So pull it back a little bit. Now when I lead my teams, okay, to do the research, or when I collaborate with people, basically, all my research projects are falling into these three areas. So traditionally, as I said, when people are interested in social science, we are always on management. We always talk about people and organization. We look after in the health and safety perspective. We look after, oh, how good is your safety culture? How good is your safety leadership? How much peer support are you going to have? That sort of more soft side of things. I'm still doing it. All right. I'm not saying that I'm throw it away. I just focus on technology. Although today, what I'm going to present you is technology. Okay. But still, I have this in my mind or as one of the area that I'm still working on. But the recent trend is that you need to couple this people-oriented thing with technology. You need to make use of the technology to enable them to work properly, or to enable them to work in a safety manner, or enable them to lower the risk of getting into health issues. And then the middle area, the new materials and process is something kind of new. Okay, I'm not expecting it grow in such a way, but gradually grow in that dimension, is because of my colleagues. Okay, they are working in introducing a lot of nylon materials in construction. For instance, adding graphene into cement. Because of that, actually the health and safety perspective, or how are you going to handle it, you need to change the process, and then you also need to look at whether you need to change, for example, like the PPE or anything else, okay, along the production process. So I have some projects actually is looking after when you introduce new materials to supply chain, what kind of things we need to do in order to protect health and safety of the workers or even the manager. Okay, so those are the three big areas, and then they are interrelated to some extent as well. But those are the areas that I'm working on at the moment. All right. Okay. And then a lovely piece of working in Manchester is that people like me who really interested of doing interdisciplinary research, or believe actually international collaboration could help to build a better solution. We have research institutes, just like this one. It's called Thomas Ashton Institute, which set up by the university and then the government. So in the UK, actually the regulator who taking care of health and safety is Health and Safety Executive. So this unique combination actually do help us to tap into government and to understand what they are doing, okay? And then they also support us when we go out to bid for research funding or working with industry. So this is just one of the institute under University of Manchester. We have many different research institute. For example, we also have research institute that looking after sustainability, net zero, that kind of things. We also have institute looking after AI, okay? So we use research institute to facilitate all the interdisciplinary research, because if we don't have this, we just sit with our own department, our own faculty, it's relatively difficult to work across the boundary. So using institute based on whatever thematic area they are advocating on, so we will work cross-disciplinary. And then for me, actually, I'm also leading one of the theme lead for this research institute. So I'm leading the digitalization and complexity theme. And then I co-lead this with HSC, the regulator, Helen Bamford, together. Actually, yesterday, we just went down to, I'm not sure you heard about IOSH. There is an institute called IOSH. It's an Institute of Occupational Health and Safety. So they also offer research grant to researcher. And then I beat that one of the research grant with Helen, so with HSC together. So yesterday, actually, right after I returned from my trip, I got an interview for the grant. So that is how Manchester is working out stuff. We basically not just purely focusing on doing your research, they advocate interdisciplinary research, and as well as you need to be able to work with the industry, work with the government for your project. So the project that I'm going to talk about just immediately is just one of the things, one of the showcase. I think it's a good example how he worked it out, something to create benefit for the society. Okay, so this is the core piece that I want to share with you guys today. So during the COVID period, many people can work from home. except for some industry like construction, because work, you cannot build something in your home, right? You need to go on site to build something. So that implies construction workers or on construction employees are under tremendous risk of getting COVID. And based on all the figures from the government, unfortunately, that is really the truth. A lot of construction workers, because of that, because of they need to work on site, they got infected. So with this background, Health and Safety Executive, as I mentioned earlier, they're the regulator of the UK government. They launch a couple of different studies. So they have six national core studies they launch in order to help different industry to cope with the situation. And then we got one of those core study to study, so we got a bit of funding to study how we can make the construction environment more safe. And then I'm in charge, of course, the project is very big. So the title is called Keeping the UK Buildings Safely. And they have phase 1 and phase 2. It lasts for around a year, maybe slightly over a year. So starting from the beginning of COVID, we already got the project to scope out what the industry is needed. And then in the second phase, basically, we are building what industry is required to help them to navigate through this very difficult period of time. So the work package that I'm in charge is we need to build a simulation model for the industry within a very short period of time. I would say this is the hardest project I ever have, because you have a very short time frame while you're not quite sure what exactly, what kind of technique actually you can do, okay? But we just pick up the challenge and deliver it. So in Manchester side, I'm the lead. And then with Dr. Akilu Yunusa Katongo, I think he is also going to present something, probably not today, but sometime later. And with
next week.
Which is good. So I'm sure he's going to give a very good talk next week. I think it's in a different topic, but Patrick, and Akilu, we work very, very closely together in the past 5-6 years. So, and then coupled with our postdoc, we have 2 postdocs, Qin Yao and Rui Feng, to help us to build this modeling. And then, of course, we work with Health and Safety Executive. They also pull in a bunch of colleagues who are in organizational psychology and also as in medical side, because this is talking about the spread of virus. So you cannot just have somebody like me who is really familiar with engineering and social science. You need to have somebody who is from medical, okay, in order to advise us, for example, what kind of model, okay, we can use. So it's a very nice combination of government and academic work together. And then on top of it, we have 4 largest contractor, Kia, Lennis, Costain, and Multiplex, to support us the projects. Because without the company's data, or a company, if they don't let you access the site information, it's very difficult. And then even you build something, they may not use it, which is useless, right? So you need to have this kind of freeway collaboration to make it happen. Okay, so I mentioned actually this piece of work have 2 phases. So in the first phase, we basically just identify what exactly they want us to help. So they clearly articulate, of course, there is some cultural issue, okay? And then there is, they want to have some more evidence-based decision-making as well. Now they're guessing, they're not quite sure, for example, which protective measure is, what kind of combination. They know what protective measure is useful. For example, if you ask people to isolate, of course, we know this is very effective. If you ask people to social distance for 10 meters, okay, that is very effective. But in terms of cost, that is an implication for doing all this as well. So you kind of trying to find an optimal point where and how I can couple those protective measures together in order to make better decision. So they want to make use of simulation and modeling, but definitely it's easier to say than work on it, right? They don't have the capacity to build all this, although they want to have it. So they tell us, can you help us to build a model which could be quite easy to use? I don't care about the mathematics that you are building at the back end, which I totally understand, okay? And then it needs to be cost effective, and then it needs to be visually presentable so that when I look at it, okay, I know, for example, on the site, which area, what time I should pay more attention. Probably I should change my work schedule because the risk that being identified through the model, so on and so forth. So that is the background why we enter into, after finish the phase 1, we enter into phase 2, which we need to build something. Okay. So now let me just guide you step by step to talk about how we build a model, okay? Although I'm not going to talk about detail in mathematics, although I'm going to show you what kind of factors we are considering and what kind of model we are considering and why we combine those models together. By the way, if you have any questions, feel free to ask, okay? I try to slow down a little bit as well. Okay, so when you talk about simulation and modeling, there are so many different models, okay, already out there. It's not saying that you need to build from scratch, but we need to spend some time to evaluate the benefit and the feasibility of those models when you want to model something in a relatively small scale, because a construction site is relatively a small scale of simulation. When you compare with modeling a country or modeling a city level, okay? But no matter what, the first thing we need to consider or we need to understand is how we can model the spread of the virus, because the core is COVID, right? So we take out a lot of different models and then, of course, working with HSC as well. And then we realize actually in the epidemic research, SEIR model, S stands for susceptible, E stands for exposed, I stands for infectious, and R stands for recovered. So this model is a mathematical model, which describe how the virus spread, okay, in the population. So at the beginning, basically, everybody is at susceptible stage. What that means is you are already, a fraction of people will contact the virus, okay? But they are not yet being infected or anything, but just like they are contacted the virus, okay? And then after a while, because for this particular virus, it will sit with you for a few days before you reach to a condition called exposed, okay? So what exposed stands for is another fraction of people coming out from susceptible, they will enter into exposed. That means they are infected already, but they are not infectious yet. So you don't get any symptoms. You don't even know you have any, you won't get sick. And then you're not at the moment, you will spread COVID around, okay? So that is the stage we call exposed. And then by time going, okay, a few days later, another fraction of people will move from exposed to infectious, because not everybody is going to show the symptoms of COVID. Some people may not have symptoms. It depends on your body condition, depends on whether you get vaccinated or not as well. So a portion of people will move from exposed to infectious. That means they got the symptoms and as well as they are going to spread the virus. So this is the most dangerous period of time, okay, for people when they end up into infectious. And then if you are lucky, you'll get recover. So a fraction of people will get recover, will enter into the final stage, but unfortunately, also a fraction of people, I don't show it in the model, will be bye-bye, okay? We will never see them again. But this is the mathematical model, actually how they describe the virus is spreading in the different stage of the lifespan of this virus. So the issue is because this model, first of all, is mathematical. This is not something they consider the movement of people, how much they contact each other, how long they contact each other. No, they don't consider it. They don't consider the interaction. they use this kind of model basically is for large scale population, like a city level, like a country level. That's the reason why they never bother about the interaction, because they believe it could cancel out each other. All right. So what that implies to us is we cannot directly just use this one. Okay. Because for us, we are modeling something which is in a smaller scale, is on a construction site with, let's say, maybe 200, 300 people only. And then every time and then in the construction sector, basically, workers work in close proximity. They work very kind of close together. And then there's a lot of interaction you can imagine on the site. And all those interaction will have an effect on whether you will change, probably you will change from susceptible to exposed or to infectious, depending on the frequency of how often you come across each other. Okay, so question mark after we know, oh, okay, we have this model, what can we do? Okay, this can be directly used. Okay, so what we do is we consider different things. Okay, so agent-based modeling is one of the models that we consider. We did consider, for example, more advanced machine learning model like reinforcement learning. But the issue is that because we don't have that much of data point, okay, at that time, so we go for agent-based modeling because it allows a bit more smaller data point. And then the beauty of agent-based modeling is it really allows the agent, that stands for people for us, because people also use agent-based modeling to model, for example, like animal behavior. At the beginning, actually, they're modeling people animal behavior. That was a starting point, just like how the birds are flying and then they create a shape on the sky. So people use the model to model those behavior. But gradually, they use it for human being as well. And then, so agent stands for people, and then they allow they account for people's interaction, and then how people also interact with the environment. So that fits our purpose, because we want a model actually do account for those interactions, and those interactions will bring out certain consequences. So eventually we land on this one, agent-based modeling. But at the same time, you need to consider the spread of the virus, right? And then we also need to consider the site layout. So in construction sector, the good thing is for the site layout, because we have BIM, okay? So what we do eventually is we combine 3 modeling techniques together. We use BIM in order to extract the site layout for us. And then we use the agent-based modeling to simulate the interaction among people, because at the same time, we also got a very detailed scheduling from the contractors, so that we can model around what time they're at where, okay? Definitely, we did consider using wearables at the beginning, but the issue, because wearables can be very accurately to detect where you are, how much interaction you have. But because we just have a short period of time, we cannot, the ethics, actually, we need to put in the ethics application. We wait until the end of the project, we still cannot get it clear, okay, to use the wearables. So we just move back, okay, let's just use the scheduling and make some assumption in order to make the model work first, okay, before maybe the next stage we can use wearable to inject the interaction information. So we use the scheduling information in order to facilitate the agent-based modeling, how the people interact on the site. And then because we are modeling the spread of virus, so we still bring in the SCIR model back, but we just model it in an individual level. So everybody, I mean, the agent, the workers that we simulate on this construction site, they will go through the SCIR process, and how they change the stage from being susceptible to exposed to infectious and recovery. It will depend on how much interaction and the intensity and the length of the interact, which I'm going to talk about more in detail later, so that they will reach to the different stage of being infected. And then on top of it, we consider, because as I shared with you guys earlier, what the company are interested in is, let's say we have 5 different control measures now. they can put on face covering, they will do the vaccination, they can do isolation, social distancing, and then the ventilation of the place. Okay, so they want to know, okay, where and when and how effective they are. So those are the questions they have. So we couple those together to build a model. All right. So this is a little bit technical, which I don't think I'm going to go through the detail. But what I want to highlight, let me see whether I put on this. Let me see. Okay, I don't have that one. So what this formula here stands for is, imagine, because we need to move people from different stage of the SCIR model, from, as I said, from susceptible to exposed to infectious and recovery, right? So we consider two parts of the factor. So the first, let me see whether I can use this one, the pen, the laser pointer. Okay, here. So the first part of this formula is we do consider personal factor. For instance, whether how old they are, what is the gender, how big is the household size, okay? Why that matter is that because based on other research, we already know people who are older, they will have higher risk, right? And interestingly, actually male have a higher risk as well than female of getting this virus. So that's why we consider gender. And then family size matters, because the larger the size of your house, okay, for example, like myself, I have kids actually at my house. The house is much bigger in terms of size. Actually, the chance of getting COVID is also higher. All right. So we do consider some personal factors in the first part of the formula when we try to calculate the risk of transmission. And then the second part of the formula, we focus on those control measures. So for example, first of all, how high is the infection rate on the construction site? I mean, in that area. And then as well as whether people are vaccinated, not vaccinated, or they have good ventilation or not having good ventilation. So because even though you don't understand all the math at the back end, if I ask you, if you're in a confined space, that means a space that have no good air ventilation, do you think the chance of getting COVID is higher or is lower?
Recording in progress.
It should be
Higher.
Doctor.
Yeah, right, it's higher. So that's the reason why you also need to consider the environmental factor when you when you try to incorporate those into the formula. So basically we have personal factor and then the environmental factor when we do the calculation. Okay, so yeah, I talk about this. And then how long actually you are staying in that place, we also consider that. So the longer it is supposed to be more risky, right, than short period of time. So those are the logic that we build in. It sounds very simple, but to be honest, it spent the most of the time to figure out all those factors that we should consider. And then we also need to draw from different study to see what threshold they're talking about, because we are not the one who studied this subject matter. Already a lot of people actually studying this subject matter, but you need to take out those thresholds to come back for the calculation. Okay, so after doing all of this, we build, because as I shared earlier, the contractors, they don't care about whatever formula, okay? Of course, you need to tell them the logic of it, just like what I share with you now, okay? What they care the most is, how can I play with it? Can you give me some interactive platform to play with it? And then can it be as simple as possible, please? Okay, I know you're a researcher, but I don't want to get into your field, okay? So we design a very simple layout for them. So what they need to do, so basically they just need to decide, they can play with it as many times as they want, just to generate different scenario, okay? So they need to decide, for example, social distancing. You can see in the interface here. So they can switch the bar, all right? For example, if they want a 1 meter, half meter, whatever, how long, okay, for social distancing, depending on how they want to roll out on the site. And then in terms of ventilation, we just give it a simple, because this is the initial one. So we just give them a choice whether you have, at least it's outdoor, indoor, or this have good ventilation, not good ventilation, they can decide it. How much percent, in terms of percentage, is it half of the people are wearing masks, or actually basically none of them are wearing masks? Do they have isolation practices? Okay, for instance, when people already getting sick, they already know they are getting the symptoms. Do they let them just stay from home, or no, actually still come back to work? But anyway, at that time, actually most of the contractors do let people to stay from home. So they may have a certain degree of isolation already, so they can choose, okay? And then also how many people are vaccinated on the site, and then the how density is the household was, so they need to make up their mind at the front end. Let me see whether I can, because I cannot see the bar. Let's see. Let me stop this one first, because I cannot see the play icon now. So hold for a second. I cannot. Oh, let me see if I can do this, because I cannot play this one. Oh no. So let me stop sharing. Let me click on that thing first, because I cannot see the bottom of the bar. Okay. Oh, okay, it's here. Okay, but let me see whether I can reshare it again. Yeah, the difficulty of Zoom is they will hide your stuff. So let me reshare that again. Share screen. So you can see my screen, right? Can you see my screen now?
Yes.
Yes.
Good, good. Let me make it bigger. Because once I enter the presentation mode, I cannot work out this bar, okay? So just bear with me, it's a bit smaller. But I think it's better to show you this quick demo. So you will see all the dots actually is rolling. Can you still see it? Oh, okay, it's here. All right, maybe that's better. Okay, so in front end, they will adjust all the parameter by themselves, all right? And then we also can fix it based on what they need. Later on, actually, we do some fine tune. And then all the dots actually going into the model is worker. And then you will see different areas are being light up. That means they are the risky area at that time. And then actually the dots, because I probably is very small in your screen now, but if you have a bigger screen, you will see actually there are different colors of the dot. That stands for the different stage of the SCIR model. And then what's more important is at the right-hand side of the interface. Actually, this can be run in 3D as well, but because of the demo purpose, we just make it simple as a 2D. So on the right-hand side, actually, they can see the first diagram. Actually, you see it here. They will know each of the timing, how many people are being susceptible, how many people are getting exposed, okay? So they know which time is the most dangerous time, okay, for them. And then the middle part of the graph actually is showing if you are doing no protection, because you have different control measures, right? So if you have nothing, not wearing masks, let's say, okay, I'm talking about second graph now. Let me see whether I can use the pointer again. Yeah. So this is the second graph, okay? So the second graph basically is showing people, particularly looking at the exposed stage. So the exposed stage, they are already infected, but not yet being really infectious. So we want to compare if you're doing no protective measure, or people who have vaccinated, or people who only have, let me see, what's this? People who are doing face covering, and then as well as if they're doing all kinds of protection. Well, how will that be different? Okay, so it's kind of like a comparison. And the final graph is telling you, actually the bottom one is telling you there are different locations on the site. So which one will be, because we are, let me see, because we are, let me close this one. Sorry, here, okay. So because we're telling them which area will be the most dangerous, okay? So just give them some idea, and then different company will ask us to fine tune this graph accordingly because they have different focus. But in a nutshell, what we want to show them is where is the most risky area, when is the most risky area. If you have this prediction, then you probably need to fine tune your schedule as well. Just like a simple thing for them to give some guidance. And because they can play with it as many times as different scenarios as they want, then they can compare how different setting will have different results in terms of the risk transmission. Okay. So, and then they can also adjust it here if they want to change and they want to play it again.
Hello.
Yes. Yeah, go ahead.
Is this application a standalone program?
Yeah, at that time was a standalone for them, but after that, actually, they just take it back and integrate into their own, because each company have a slightly, actually very different system. So they integrate it back to, sometimes I think for multiplex, actually they did work it out further and try to link it with Beam, because no matter what, you need the integration, you need the sources from Beam. Yeah. So, but to answer your question, yes. It was.
Next question, doctor. Is it a free application?
Actually, for building, this is not free because we did use software called AnyLogic, okay, to run this agent-based modeling. The reason why we choose a non-free version is because we don't have enough time to build from scratch. Okay, so we need to have something that is easy for us to work out all the coding. Although we still need to work out the coding, but it's far less than because there's so many open source platform for agent-based modeling as well. But if we go for those direction, it will take you maybe 1 year, over a year, to develop all the stuff. So it's not free. We did pay for the software, but it's in a reasonable amount, I would say. Affordable amount.
Thank you, doctor.
Yeah, but thanks for the question.
Dr. Clara?
Yeah.
I have question. Does each employee use a special device to track their movement within the site?
Yes and no. Okay. So at the beginning of the project, because HSC, I mean the regulator, they do want to. They buy a lot of wearables. Okay. And then our dream is to deploy, okay, those, okay, not to get the location of people. But as I said earlier, because, in the UK, probably is very different from Malaysia. We need to go through layers and layers and layers of ethics approval. And then we only have half year, okay, to finish the project. So eventually, we don't have time to wait for the clearance of those devices to deploy on the site. We need to go ahead to use the schedule in order to mimic how they moved or when they are going where. But I would say it will be much better. And then actually, this should be the direction as well. I think for future study, if they are really interested in coupling the movement, then the wearables is really the source of doing so. But definitely, that will be challenge as well when you use wearable to collect those information. Because, for example, people moving on different floors may create noise in your data. So there will be challenge as well. You need to spend time actually to make sure the data collection is making sense. For instance, because we do think about those kind of scenario at the middle of the study, because we know probably we can deploy the variable. For instance, if you have the hub, okay, on each floor, okay, instead of just one hub in the entire maybe 3 floors, that will help you to clear what I was talking about. You don't know which floor they're working in. You know they're moving, but you don't know where they're moving. So it's very problematic. Yeah, but yeah, we don't have it for this particular project. It would be nice to have it.
Thank you, Doctor.
Okay, thanks. Very good question. I really like the students here. Always have questions. Not like in the UK, especially when you talk to people who are not really working this industry. They are just, oh, nice. Okay, I want to learn the model, but that's it. So thanks for all the good questions. Okay, so let me try to see whether I can move to the next one. Okay, so as I said, because people can build, because later on we publish a paper, so we need to kind of, and then we also show it to the contractors as well. So in order to simplify the showcase, although the paper actually we publish, we have 108 scenario because you have 5 different control measure, so we could generate 108, okay? But in order to simplify the explanation, we basically just make 3 different scenarios to showcase how it could work, okay? So the first scenario is there's no control, okay? So basically nobody's wearing masks, there's no vaccination, people maybe just do a little bit of social distancing, no ventilation, no isolation. So this is scenario 1 as a non-control safety, so no compliance on the safety control measure. And then the second scenario is just middle, okay? So maybe you have half the people wearing masks, you have half of the people do the vaccination and 1 meter social distancing, you have ventilation, and then you have the isolation as well. Then the first scenario is just pushing it to extreme, okay? You are complying to all this in 100%. So based on those 3 scenarios, then we can just run to see how many people will, by what time they will end up into different stage of being susceptible, exposed, recovery, so on and so forth. Just as a showcase, okay? All right, so if you still remember, the first stage of this is susceptible, right? So people are just exposed, a fraction of people are exposed to the virus, but not yet, nothing really happened. So the longer time people can stay in this stage, the better it is, right? That means they're not getting into a sick situation. So when you look at the line here, so the blue line actually stands for the scenario, which is full compliance. So that means they are wearing masks 100%, they are doing the 2 meter social distancing, they're 100% vaccinated. Of course, we know that will be the best scenario, okay? In terms of you're holding the most people in this susceptible stage, we know that it's nothing that surprising. But the issue is when you look at if you're practicing the middle compliance and no compliance, how will that be different in terms of holding people into this susceptible stage? So what we found is even if you do a middle compliance, you will delay around 52 hours of people getting into the next stage, okay? So they will have 52 hours longer staying into this susceptible stage, okay? Then next we look at the other stage. So this is talking about the isolate. Then the next stage of this is after you being susceptible, then it's exposed, right? So how fast actually people are jumping into the exposed stage. So the same thing, not very surprising, full compliance is working out the best, okay? While when you focusly look at the middle and then the non-compliance one, for this time, if you even do a little bit of middle ground compliance, it will delay 27 hours from getting into it. It seems like but never bother, right? Just 24 hours, 26 hours. What does that imply? But when you play a lot of different scenario, you will see actually how the benefits could be. And then at least you have some decision point. Is it worth doing this or basically it's the same? Okay, no matter you comply, not compliance, the rate is very similar. Then maybe the company would decide, okay, don't bother. All right. So this is just to showcase, okay, if you do that, okay, how many in terms of a little bit mathematics, how long can you drag it for? So the same logic when we look at the next stage, when you get into infectious, all right? So never mind, never bother the full compliance. If you look at the middle and then you look at the non-compliance, it will also give you significant difference around 52 hours time difference. People will get into this very dangerous infectious stage. So the final part is just recovery, which is less interesting, okay, when you're comparing with the previous three, but still you will see the full compliance one are working the best. Because why the number is lower, the full compliance? Because you get less people sick. That's the reason why you get less people getting recovery as well. So that's why the line is much lower than the other two, okay? All right, so this is just a showcase to let them know if you plug in different scenario, this is one of the angle they can look at. And because, as I said, this is also for a publication, because eventually we publish this in Safety Science. So we also run kind of a sensitivity and then the correlation analysis to see which kind of protective measure probably give you the best, the highest correlation of being effective. And the darker the color it stands for more effective it is. So eventually, I think it's not very surprising. We figure out if you do the isolation and vaccination is the most effective thing, comparing with social distancing or wearing masks. I don't think it's very, I don't think it deviates from what we thought, but it just strengthened the things that we find somewhere else, not in the construction sector. And then because this project mostly is not, I would say it's not to fulfill the academic purpose, to be honest. Usually when I run a study, it won't be just like half a year, it will be much longer, but because of the needs of the industry. So that's the reason why at the end of the project, when we deploy, when we showcase how they use the modeling techniques, we also collect the feedback from the industry in all the dimensions that I listed here in order to fine tune the tool. So this is quite, I think it's quite a handy criteria whenever you deploy a technology, what kind of aspect you can look at. And eventually we got some, I think, yeah, because we have 4 contractors. So we all got very positive feedback on it's quite handy to use. And then eventually they integrate it back to their system, but it's up to them how they want to integrate it. But at least we give them some hint on it's possible to work it out, and then it could be tuned according to the site as well, given that if you have the beam data to load it there, yeah, it could work out the rest. All right. So eventually, after a long journey, okay, we start the project in 2021 in phase 1, and then eventually we deliver phase 2, and then in 2022, and then our publication actually is the end of last year. We published this in Safety Science. So if you're interested in the detail of the model, please feel free to read it. Let me know in case you cannot access it as well. So all the detail, the spec, and how we design the model, how we run the model, the data are there. And last but not least, I think very positive feedback from the funding body as well, because we showcase all this, and then eventually we won a prize actually from UKRI, our UK Research and Innovation. Yeah, it's a government body as well. So we won a prize on being rapid assistant, the modeling in the pandemic. So we won a small grant in order to showcase this to the wider audience, because we work closely with the 4 contractors. So we want to reach out to more construction firms. So we make use of this award and the grant to go to the Digital Construction Week in London to showcase to others how this could possibly work. So I think that's it from me. Hopefully, I don't think it's too technical because I don't go through the mathematics, okay? So any questions so far? And anyway, thanks for all the good questions along the presentation as well.
Doctor, good morning in Britain time. I have a question about model RAMP. So we all know that there are a lot of no symptom people in the late stage of COVID-19 who didn't even know they have the disease. How to build a model if it is COVID-19 infected person with no symptoms.
Ah.
This will affect the accuracy of the model.
Yeah, actually, we do consider a portion of people because, of course, we can never, because you are not doing a medical exam for everybody. We need to admit that, okay? So we can only predict the risk instead of the accurate results, okay? But in the model, we do consider a portion of people will end up into asymptomatic infectious stage, okay? But how accurate it is, it's difficult. I can just say this is a limitation because you're not first of all, you're not drawing the physical sample from the population on a daily basis. So you can only base on what government collected as a general picture to put it back as a parameter in your model. So that is the limitation. But at least you have something for the industry to say, okay, if you do this, probably the risk will be high. Okay, if you do that, maybe we could lower the risk.
Thank you, Doctor.
Yeah, thanks for that. I hope we can have a perfect no limitation model, to be honest. I also asked the same question, okay? When I build this, can we improve? Yeah, there's so many asymptomatics, okay? At the end, yeah, you're right. At the end of the pandemic, it's very difficult. It's getting into, but at the same time, the good news is at the end, the later stage of the pandemic, people are not getting so serious, even they get the virus, not at the beginning. At the beginning, it's really awful. So I think it's also a balance when whatever we build for the industry, you're striving for accuracy or you're trying to, not that accurate, but at least they have something to use it first so that to alleviate the problem, to lower the risk first. Okay, that's always a balance. So any other question or thoughts? Actually, it's very good. I thought I only need to use 15 minutes for the presentation. Eventually, I use up the entire hour. But I think it's better to slow it down and then you guys can ask questions along the presentation. I think this style is more relaxed, okay? I got to know the Malaysian culture more. I appreciate our Malaysian culture, which is people are friendly and then we can relax a little bit. You don't need to rush in, okay? Because I have been in Malaysia. Actually, yeah, and I enjoy food there. Actually, what I miss the most is the food, okay? Besides people. You know, UK is notorious for it.
The lecturer also give compliment of them because they always ask the question.
Yeah.
Yes, they're good.
It's really good. Yeah,
Yeah.
I mean, the interaction is, I think, yeah, even work as an academic, I think the most valuable thing for me is the interaction with
Yes.
students. And especially students who are working in the industry, because those kind of bouncing back and forth will help us to think more differently,
Very
basically.
different because we are in the academic. It's different on the industry. We need to knowledge from the industry sharing. Yeah.
Yeah, definitely.
Any other question, guys?
Yes, I have one
Yes.
question, Doctor.
Yes, please.
Yeah, I believe you have the actual scenario during the COVID after they're using this application. What the percentage of effectiveness of this?
Actually, I did not collect the data how effective they are, but based on the feedback, I mean, the contractors give it to me. They just say, yeah, but basically at the not the later stage, but the early stage of the pandemic is very useful. At least they have something to base on to basically redesign the work schedule accordingly. That's the feedback I got. But as I said, because this is not a prediction on how many people really getting infected, this is just predicting the risk. If you're doing so, how high the risk could be. Yeah, so not sure answer your question. So, but at least they are saying that, yeah, they're using it. But actually this model, I would say, is not just for COVID. I think for any type of airborne disease, because for example, like flu, I don't know how serious is in Malaysia, but in the UK, every winter, we have very high number of death toll because of flu. So yeah, this kind of model, that's chances we can use in that outlet as well, given that COVID is over.
Okay, okay.
Dr. Clara, I have question.
Yeah.
Is the development of this modeling, SIER modeling, still ongoing to face another pandemic wave in the future?
I hope I don't need to do it again. Yeah, it's good for my research, but it's very bad for people. Okay. But I would say it's more prepared if we end up into a similar situation, given that not just my research, a lot of researchers already, you get used to this space already. So originally, I'm not in this space, although I'm in health and safety, but I'm not in infectious diseases. It's totally different stuff. But because of this, we end up into studying this more. So hopefully, in the future, if we have the same situation, we can pull up what we have learned this round to cope with the next round.
Thank you, Doctor.
Yeah, thank you. Okay, so I think I should let them go. Okay, they should take a rest before Patrick. Otherwise, they should feel very tired for Patrick's session.
Okay, thank you, Dr. Clara. I think we can take a picture first. Anyone, you can please open your video, touch up your tudung and also whatsoever.
So it's time to switch on the camera.
Yeah. All right, are you ready, guys? Yeah, I need to snapshot. Wait, wait. Okay, okay, ready, 1, 2, 3. All right. Okay, thank you, guys.
Okay, thank you very much.
Thank you very much. So until we meet again. Okay. So anything we touch up with you. All right. Okay. So guys, any thought to Dr. Clara?
Yeah, I think
Thank you,
that's
Dr. Clara.
very good. Yeah, thank you. Okay, see you
Thank you,
guys
Doctor.
later.
Okay.
All right.
Bye.
Have a
Thank you,
good
Doctor.
Thank you, Doctor.
evening. See you
Thank
then.
you, Doctor.
Okay. Okay, guys. So okay,
Thank
Dr.
you,
Clara.
Doctor.
All right. Oh, still on the way balik
Oh, ada. Tak boleh kerja lagi.
Okay. Alright, okay, so we rest until 8 o'clock. Please join early. I think a different link. Will share in your WhatsApp group the new link for the Dr. Patrick menu. But please come early. We start at 8. Okay, but please join early, 7:55 maybe. Alright?
Okay,
Okay, guys.
okay.
See you.
Okay, Doctor.
Okay.
See you. Bye.
Bye.
Thank
Doctor.
Okay.
Selamat
Jangan
raya.
tak join jangan tak join. I record the video.
Okay, Doctor.
Right. See you.
Meow.